If you are needing some help with the difference between bars, barrier beaches, offshore bars and barrier islands, then this is the video for you to have a listen to. Explanations will be clear, there will be some diagrams to support you, and there will also be some key examples. So let's start with a bar. So in the diagram, you have got the land area. The two H's with a circle stand for a headland. So what you've got happening is on that left-hand side of the headland, swash and backwash moving along the coastline. So the swash being the arrow moving towards the land and the backwash being the movement coming away from the land. As that swash and backwash move sediment along the coast, by the processes of traction and saltation, so a bit of revision for you there, just have a moment to think what they are before I tell you. So traction is where the sediment rolls, saltation is where the sediment is bounced. Now that movement of sediment as a whole is known as longshore drift. That longshore drift builds up sediment for a start at the edge of this headland just here. And as that sediment builds up, it will actually block off the area of the coastline behind a bay, basically. The sediment will meet the other side of the bay, the other headland, and block off the water behind that was in the bay. That is then known as a lagoon. The feature that is created that blocks off that bit of the bay is a bar. Now, I'm sure lots of you are thinking, is that a spit? Yes, it may have been a spit if it had only reached, say, that point there, if it had gone from that headland there to there, but because it now hits the other headland, that is now known as a bar. Now, for those of you that are getting confused between bars and barrier beaches, if I just pull over to the right-hand side, a bar is also known as a barrier beach. How confusing is that? Some textbooks, if you do some Google searches, may not tell you that, but AQA will accept that a bar is the same as a barrier beach. Who knew? Example is a place in Devon called Slapton Ley. Google it if you want a quick picture just to cement that in your memory. Characteristics are that it's linear, which means it's in the shape of a line. It's a ridge, not particularly very high. It's narrow. It can be made of sand or shingle, so a mixture of both or each of them. It is low-lying, and you get vegetation growing along that bar, which, like sand dunes, will actually make it more stable. It will hold it in place. What do you need for this to happen? You obviously need erosion, because you need erosion for the sediment to be created, and you need quite a lot of sediment for something such as a bar to be created that actually sticks out above the waves. You then need the process of longshore drift with the swash and the backwash that make that up, and then you need the deposition, and you need again a huge amount of deposition. And for that to happen in this environment, you need the ocean to be not moving as quickly. You need it to be a low energy environment. If I just move back to the left hand side, not to make everybody dizzy, if that bar links a piece of the mainland to an island, it has the wonderful name of a tombolo. Again, just do a bit of Googling and you can find some beautiful pictures of that. But a great example of a tombolo is Chesil Beach in Dorset. Right, here we go, next one, offshore bar. So offshore bar is as it says. It's a bar of land, a deposited area of sediment offshore. So if you've got the land, like you see in this diagram, and the offshore bar is offshore, it has been again created by exactly the same processes of the swash and the backwash. So again, you've got your longshore drift going in that direction. But this time the backwash, so this movement here is really strong. The amount of sediment being pulled back is quite a huge amount, because as that sediment gets pulled back with the backwash, it then deposits it offshore and creates this offshore bar. Example, Christchurch Bay, Hampshire. Characteristics are very, very similar to our bar or barrier beach. Linear, ridge, narrow, sand or shingle, again low-lying, and it can disappear. So most times an offshore bar will only be visible at low tide. But if you get some really bad storms on that area of beach, the backwash could actually take that sediment away and just redeposit it elsewhere. So they're not permanent features. Well, you could argue a bar isn't a permanent feature, because with big storms, erosion, etc., bars and spits can disappear. What do you need is the strong backwash, again a big supply of sediment, so therefore you need erosion to be happening, and obviously you need that deposition to be happening. And finally, if I just pull that away, the barrier island. So I'm just trying to make it so you can see the whole page there. So a barrier island starts out as a bar, offshore bar, or even a spit. So you're basically going to use the same knowledge as we've just used for the information above. So if we look at the bar, if I home in on that bit. So a barrier island needs to be an island. That's where the difference is between all of these different depositional features. So if it starts off as a bar, you've got the same process as the top diagram. Let's move it way up to that one there, look, but I've just drawn it a little simpler. So here's your bar. Your longshore drift is obviously doing that, but somehow the bar gets chopped off. So here and here, so to the right of that line and to the left of this line here, that area could potentially become eroded. So maybe, as I was talking about before, maybe a storm. So therefore the bar becomes detached from the land basically. If it starts out as an offshore bar, then similarly the same process creates your offshore bar, but what actually happens is that offshore bar has to become a more permanent feature. So you have to have more deposition, which makes this offshore bar grow and become higher. That might take quite a long time, and with both of these two, vegetation could play a part in stabilising these barrier islands. And if I just come to the very last one, now I've not talked about spits. If you're not sure about spits, just check your A-level notes that you've got from your class teacher. But if you have a spit that is protruding from the land, so the land is obviously here, ocean here, the spit will grow because of longshore drift. But what has to happen is the spit has to become detached. So somewhere in this area here, for example, you might get accelerated erosion. So therefore this bit of the spit disappears and the spit becomes detached from the mainland. So again, you've got a piece of land that is detached from the mainland, i.e. an island, but it then gets classed as a barrier beach. A great example, or a coastline actually, where you get lots of barrier islands, so I might have said barrier beach there, sorry, barrier island, is North Carolina coast in North America. Just do a quick Google, have a little look at that coastline, and you'll see strips, thin strips of linear land off that coast. So the characteristics of these are all the same as the rest of the other features, as the barrier beach and of the offshore bar. Let me just flip my board over. If you do want to have a little look at a question, now this is actually an AQA question. Outline the processes which lead to the development of barrier beaches, 4 marks. Have a go at that. It's a 4 marker, so don't forget the rules on 4 markers. Ideally 2 great ideas expanded. And the key word in this question is this one here, processes. So it's really important that you talk about processes, not characteristics. So I'm hoping that your brain's thinking longshore drift, if you want to break that down, the swash and the backwash and the saltation and the traction, and the fact that you need a huge amount of deposition and potentially erosion to actually create the sediment in the first place. Hope that's helped to work out the difference between the bars, the barrier beaches, the offshore bar and the barrier islands.